Welcome to Real GMAT Problems, episode 14. Doing real GMAT problems is a great score mover. The problems that we are going to go through today are from the 11th edition of the official guide for GMAT review, and you can web search them if you would like to follow along visually, even though I know many of you will not be in that situation. Just so you know, the 11th edition of the official guide for GMAT review is out of print. And that's partly why I'm going to go through the questions from that book, because that way, if you purchase this year's official guide, there shouldn't be any overlap between these questions that we're going to work through here and the new version of the book. The official guide contains retired problems that have appeared on past GMATs, so it's a great way to take what I'm going to recommend here and get even more comfortable executing on it. I'm going to read each problem and then I will give you a chance to work through the solution on your own if you want to. And then I'm going to discuss my thoughts on the problem and my recommendations for what to learn from each one. What I recommend is pausing after I read each problem and at the very least thinking about what your solution would look like. So even if you're on the go, do some mental visualization about how you would work through the scratch work one step at a time and get as far as you can. You may not be able to get through every single step in your head, but see how far you can get. And it's a great challenge. If you are on the go, but you have access to pen and paper, like if you're on a plane or someone else is driving, that's ideal. Let's jump in. This is problem number 46. The problem says, how many integers n, like the variable n, how many integers n are there such that 1 is less than 5 times n plus 5, which is also less than 25. So you've got a compound inequality there. You've got 5 times n plus 5 in the middle. To the left, you've got that's greater than 1. And to the right, you've got that's less than 25. I'll read the problem again. How many integers n are there such that 1 less than 5n plus 5 less than 25? So it's basically asking you how many different integers are there that could fit that inequality as the value of n. Option A is 5. Option B is 4. Option C is 3. Option D is 2. And option E is 1. Take a moment and visualize how you would solve this. I recommend pausing the episode if you can, because I'm not just going to leave 2 or 3 minutes of dead air here. Super interesting problem here. The correct answer is B, as in beta. There are 4 integers that can satisfy the given inequality. But a full 7% of people pick A and 17% of people pick C. That's definitely way too high of a probability that people are missing this one. Like basically a quarter of people are getting this wrong. So let's dig into a correct solution path and then we'll think about where the pitfalls are and how you can avoid those. First, there are quite a few ways to execute the algebra in a situation like this, but the main solution path is just executing algebra. So I'm going to walk you through how I would do it, but as long as your solution works and you feel it's repeatable, there's no need to execute the exact steps that I'm about to walk you through in exactly the same order as I'm going to. Now, what I like to do in these situations is I want to isolate the variable n in order to make the problem easier to think through. So the first thing I'm going to do is I'm going to subtract 5 from each part of the inequality. When you have more than 2 values in an inequality, like A is less than B, which is less than C, that's called a compound inequality. The good news is that the golden rule of algebra, which is whatever I do to one side of an equation, do the exact same thing to the other side of the equation. That applies to inequalities as well. So whatever I do to one side of an inequality, do that same thing to the other side. And it also applies to compound inequalities. I just have to do the same operation to all 3 or all 4, however many parts of the compound inequality there are. There's 3 parts here. So as long as I perform that -5 operation on all 3 sections, I'm not going to change the relationship. Now, inequalities is a little bit deeper topic than that. So if you want help understanding the basics of inequalities and how to operate on them well, we've got a math basics episode on that topic specifically linked in the description of this content. So highly recommend that you check that out if you feel like what I'm about to walk you through is like not 100% on the level that you want it to be. Let's put it that way. So compound inequality from the problem is 1 less than 5n plus 5 less than 25. So I'm going to subtract 5 from all of those. That's going to give me negative 4 is less than 5 times n, which is less than 20. Now, if you want some help with basic algebra and how to manipulate this stuff and using that golden rule I was talking about, we also have an episode of Math Basics linked on that for you below also. So we've got negative 4 less than 5n less than 20. I want to isolate n, so what I'm going to do is I'm going to divide each part of the compound inequality by 5. That's going to give me negative 4/5 on the left, which is less than n by itself, which is less than 4. And now what I can do is I can just count all the integers that fit that range. Recall that the definition of an integer on the GMAT is no decimals and no fractions, which does include 0. 0 is neither positive nor negative, but it is an integer and it is considered even on the GMAT. If you want more help with basic definitions like this, please check out episode 1 of our Math Basics series and the final episode called Special Cases. That's where I go into some of these core definitions that are super, super important, as you can see from this problem. And that's why that we took the time to make that material for you. So highly recommend engaging with that. It'll help a lot. And those 2 episodes are linked below also. The first allowable integer in our range of negative 4/5 up to 4 is 0. But it can't be negative 1 because negative 1 is going to be less than negative 4/5. So 0 is the absolute minimum integer that fits within our range. The other numbers that fit in the range are 1, 2, and 3, but that's it. So 0, 1, 2, and 3 are our options. And that's how we get 4 integers that satisfy the inequality. And that's how we get to the correct answer of B, as in beta. And that's probably the ideal solution path for most of us. Again, plenty of different ways to execute that algebra. You don't have to follow the exact steps, but the kind of basic thrust of that technique of using algebra to simplify and then figuring out what the range is going to be the most helpful for the widest number of people. Now, some of you might have been able to get that answer without simplifying. That's fine. Again, as long as your solution path is repeatable, I think it's okay. But if you find yourself making mistakes or getting confused with your existing solution path, then I recommend adopting the one that I just went through. Now, if you have any questions about the techniques I'm recommending or any of the material we cover in these episodes, then feel free to DM us at the GMAT strategy on current social channels anytime, or you can send us an email. Our public email address is contact, CONTACT, at thegmatstrategy.com. And we're more than happy to help if you need help with any of this material. So let's think about why so many people pick C. 17 out of 100 future business leaders of the world are picking option C here. And I think that's way too many. I hope you agree. So what people are doing here is probably forgetting that 0 is an integer. We all forget things. So if you're practicing right now and you didn't know that about 0 or you learned it and forgot it, that's super understandable. We're all human, but we definitely do not want that happening on test day. So think about what's helped you memorize things the best in the past. I've found that flashcards are often the most common and most helpful thing for memorizing, but there are other methods that that work well for memorizing things for certain types of folks. So figure out how you can integrate whatever technique of memorization has worked best for you in the past into every single study session going forward. If you don't have a good memorization technique, just do a web search on how to create and use flashcards in your study. And within 5 to 10 minutes, you're going to be building out a great memorization system. And the key from that point forward is just staying consistent with it. Because obviously creating a flashcard or creating a study sheet to memorize things is a really important step. But if it's not a living, breathing thing that you're working on a regular basis consistently, it's very likely that even if you knew that 0 was an integer at some point, that it's going to fall by the wayside. And of course, we don't really care if you knew that 0 was an integer right now today, because you're probably not taking the GMAT right now. At least I hope not. But you will take the GMAT in the future, and that's the day where we want all that stuff to be fresh in your mind. And having a consistent memorization approach in every single study session is the way that I have found that works the best. I like to personally use memorization as a warm-up before diving into new material, but other people have different philosophies. And as usual, the key is to figure out what works for you and commit to just doing that on a regular basis. So please find a way to memorize basics like the definition of integers every single time you study. It'll pay major, major, major dividends. For convenience, by the way, if you are on the go a lot and you're listening in the pure audio feed here, we've got a audio flashcard set at the start of every Math Basics podcast episode. So I lead off every single episode of the Basics series with a quick quiz that can serve as like a digital flashcard set. And you can test yourself on whether you truly know these core basic definitions, which, as you can see, are heavily tested on the exam. Because 17% of people appear to not know the real definition of an integer, let's try to head that one off at the pass, everybody. We're in this together. Business leadership improves when all of us improve. So let's start by improving our knowledge of the number zero. So why might people pick A? There could be a few reasons. Maybe thinking like -1 works. That's one possibility that I thought about. But my guess is that they do 20 divided by 5 when they're simplifying, and they write it as 4. They do 20. Sorry, they write 20 divided by 5, and they write that as 5. 20 divided by 5 is 4. But I could see a lot of people writing 20 over 5, or just thinking 20 divided by 5 in their head and then writing the number 5. I've definitely seen a lot of people make that kind of error in the past, and that would naturally lead to option A, because that's going to fit another integer into the allowable range. So either way, a lot of people picking A, a lot of people picking C, and a full quarter of people getting a question at this level wrong, I think is just unacceptable. Again, if you got it wrong today, like that's fine. That's understandable. You just want to learn from it. But by and large, I think we should really, really try to make sure that you know your stuff well enough to have a 0% chance of missing something like that on actual test day. So those are my recommendations for that. Now, in terms of people picking A or making those kinds of computation mistakes, I've discussed my recommendations for good quality scratch work in the past couple episodes. So please go back to those, which are also linked below if you want some advice around how to prevent yourself like making that kind of mistake if you find that that's something you're prone to. In general, the core recommendation is you want what you write down as you solve the question to be clear enough that someone can look at what you wrote down and see exactly how you thought through the problem without having to talk to you. That's a good metric for whether your scratch work is clear enough. And that's way, way higher of a bar than most people are setting for themselves. I think that's the right place to raise the bar, to set the bar. That's the thing that I've seen people have the most success with. I think it's natural for people's scratch work to degrade a tiny bit under time pressure. And so you want your scratch work bar to be even higher than the minimum that you would accept on test day in your practice, so that if it does degrade, you still get a really good result. And if you do the math on the upside of every single question that appears on the exam in terms of lifetime earnings or just lifetime impact, whatever your thing is, I think you'll agree that writing stuff down is a pretty darn good trade-off there. So some good lessons to take away from that one. We're going to re-emphasize a couple of those as we go through the next problem. Next couple problems. So let's pause briefly and let's try another one. This is problem 46. The problem says a dealer sold X used cars and Y new cars during May. If the number of used cars sold was 10 greater than the number of new cars sold, which of the following expresses this relationship? We've got a few inequalities and equations in the answers that I'll read in a second. Let me reread the problem. A car dealer sold X used cars and Y new cars during May. If the number of used cars sold was 10 greater than the number of new cars sold, which of the following expresses this relationship? Option A, X is greater than 10 times Y. So that's X greater than symbol 10 times Y. Option B, X is greater than Y plus 10. That's X greater than symbol Y plus 10. Option C, X is greater than Y minus 10. That's X greater than symbol Y minus 10. Option D, X equals Y plus 10. Option E, X equals Y minus 10. Again, recommend pausing and working that out, or at least imagining how you would work it out. Great problem to make a few points about translating English into math. The correct answer here is D, as in delta, but 7% of people pick B and 5% of people pick E. So again, let's dig into a correct solution path and then let's explore what could go wrong and how to protect yourself from those kinds of mistakes. The first potential correct solution could borrow from the percent translation approach that I spoke about in the last 2 episodes. And those 2 episodes are linked in the description below, or you can just scroll back in the feed to episode 13 and episode 11. Actually, it's not episode 13 and 12, it's episode 13 and 11, respectively, that I discussed that in. And the basic breakdown is what means a new variable, of means multiply, is means equals, and percent means divide by 100. I'm kind of glossing over that, but that's kind of the basics. So this one says the number of used cars sold was 10 greater than the number of new cars sold. So number of used cars, the problem already defines that as X for us. So I'm just going to write X. Was is the same as is. So that means equal sign. 10 just means 10. And then greater means addition. So we have number of used cars is X. Sold was means equals. 10 means 10. Greater than means plus. Than the number of new cars sold, which the problem defines as Y. And so we can just go through that simple translation algorithm and wind up with X equals 10 plus Y. So that's one approach, and it is a very, very good one. If you practice with it and you get comfortable with it, you're probably getting this right super fast and super reliably, which is great news. Now again, episode 11 of this Real GMAT problem series is linked below if you want to learn more about that percent translation approach. I do want to give one word of caution that this type of translation is not as reliable in all word problems as it is in percent translation problems. Clearly, this one is a percent translation problem, so it works, but it's not always guaranteed to work in questions that are word problems that don't involve percents. So you may want to just double check if you're using it in word problem situations more broadly, because if you're not supremely confident you've translated everything correctly, then that can lead to a lot of bad downstream effects. So one way that you can double check yourself if you're going to use this strategy more broadly is actually using the plug-in numbers approach that we've used in past Real GMAT problems episodes. If you want to learn how this approach works, then I've got a lesson specifically on it called How to Plug in Numbers, and we'll link that episode in the description as well. So feel free to listen to that and circle back to this one if you're not sure what I mean by plugging in numbers. But let's just say we wanted to do a quick double check here. We can just make X 20 or something like that, and then plug that into the problem. And the problem would then read, if 20 is 10 greater than the number of new cars sold, then you could say, great, the number of new cars sold is 10. 20 is 10 greater than that number. What number is 10 less than 20? It's 10. Or what number that if I make it 10 greater would equal 20? That's going to be 10. So that lets us solve for Y. And you can either use that as a validation approach for your algebra, or this could actually be your whole approach to the problem. Note that we do have variables in the answers here, which is the main trigger that lets you know you're allowed to plug in numbers. And so I definitely would not mind if someone just took this approach from the very beginning. I think there's a lot of upside there. Note that if you plug in X equals 20 and Y equals 10, then delta is the only option that would actually work there. Okay, so those are 2 very viable solutions. Let us know if you struggle with either of those, like I said. Let's turn to option B, though. X is greater than Y plus 10. This is really concerning that people pick this one because it shows a lack of understanding of how equations work versus how inequalities work. When translating English into math, due to time pressure or lack of practice, sometimes other psychological factors like anxiety, people often see the words greater than and they just automatically assume that it's an inequality. But it's worth getting familiar with a little bit of nuance here. If something is a specific amount greater than something else, such as 10 greater or 20 greater, like we're dealing with in this problem, that is an equation. That's what we have here. X is 10 greater than Y. That's a specific amount greater. Again, that always is going to lead to an equation. Inequalities happen when it's not a specific amount greater. For example, X is greater than Y. Notice it's not a specific amount greater than Y. It's just generally greater than Y. That's how you wind up with an inequality. So if you struggle with that, or you could see yourself making that mistake in the future, please create a flashcard or add that to your memorization system and study that on a regular basis. Again, if x is a specific amount greater than y, like x is 10 greater than y, that's an equation, x equals y plus 10. If x is not a specific amount greater, it's just greater than y, that's an inequality, x greater than symbol y. That should help you avoid picking answers like B. Again, 7% of people are choosing that, which in my opinion is just way, way, way too many. If you take 100 of the brightest minds in business leadership and 7% of them go for B on this problem, that's an issue. That's an issue that is very resolvable and fixable. And so hopefully we just fix that. Regarding E, which 5 out of those 100 people would have chosen, this kind of looks like people are getting turned around between X and Y and the new and used piece. This again is super understandable given the time pressure and how difficult some questions can be to read, but it's still not a risk that we want to take on test day. So if you made that mistake today, that's fine. We just want to fix it. I think the best way to prevent yourself from making that kind of mistake is just to define your variables extremely clearly, and that means writing them down. So make sure that you have X equals used or used cars and Y equals new or new cars sold or something like that written down on your scratch pad. Now, if you're on the go and you're visualizing it, then I just want you to, in the future on word problems, visualize yourself writing X equals used, Y equals new. Think about how long that takes you and how much energy that takes versus the upside of reducing the risk that you're going to pick something like E. Like just imagine that writing that would give you a 5% greater odds of success on this problem. If you do the expected value calculation there, it's going to net out pretty darn positive. So a lot of people resist that kind of thing for a lot of reasons, and I used to be one of those people, so it's a very understandable situation. Things like time or energy come to mind as objections to writing things down, like, oh, I don't have time to do that, or like, oh, I don't need to do that. I'm going to get the problem right anyway, like things like that. Listen, if you're never making those mistakes, that's great. Keep doing what you're doing. But I was not that person. I made tons of those mistakes, way, way, way too many. I was definitely in the 7% and the 5% on these kinds of problems way too often. And so I recommend writing down your variables. And the trade-off, I believe, like I said, is going to be more than worth it. Certainly has been for me and literally every person I've ever talked to about doing that. So just something to consider. So just pause, think for a moment. Is there anything you can learn from this problem that might improve your approach? I'd recommend writing that down and making a flashcard out of it or adding it to your memorization strategy. Again, working on memorization every time you study is going to have a massive, massive ROI. Let's see if we can complete one more of these together. This is problem number 48. The problem reads, if a 10% deposit that has been paid toward the purchase of a certain product is $110, how much more remains to be paid? Let me read that again. If a 10% deposit that has been paid toward the purchase of a certain product is $110, how much more remains to be paid? Option A is $880. Option B is $990. Option C is $1,000. Option D is $1,100. And option D is $1,210. Go ahead and pause and make some progress on this one, either on your actual scratch pad or visualizing how you would work on this. Sticking with the theme of translating word problems into math here, we'll be able to pull some of our recent notes to make this one a little bit easier. The correct answer is B, as in beta. $990 remains to be paid. The language of this problem really messes with people. In fact, a full 15% of people are picking D, as in delta, which you might recognize as the actual price of the item, not the price that remains to be paid like the question asks us for. So we'll talk about how to avoid that kind of thing in the future. It's extremely, extremely common, right? So imagine the 100 of the brightest future business leaders in the world standing in a room and 15% of people are picking 1100. 15 of those 100 people are picking 1100. We don't want that to happen, everybody. This is a very preventable situation. As usual, there are a couple possible solution paths on this one, but probably the most straightforward for the largest number of folks is just to use that percent translation approach that I have spoken about so much in past episodes and today. This is part of the reason I wanted to give that to you because it gives you a lot of leverage. So again, what means a new variable? Percent means divide by 100. Of means multiply, and is means equals. Notice how we can apply that here. A 10% deposit, that means 10 over 100. That has been paid toward the purchase of means multiply. So 10 over 100 times a certain product. Now, this is a little bit of a departure from what we've done in the past. We don't have a value for that certain product, so we can create a variable for that unknown. Let's just call it P for product. So we would have 10 over 100 times P. Then notice the is 110. Is means equals, 110 just means 110. So that would give us the equation 10 over 100 times P equals 110. Now, again, this is a little more complex than some of the earlier examples we've used this translation algorithm on because we have to ignore the has already been paid part at the very beginning in order to create this equation for the original price of the item. So this is where we're starting to get into some of these word problems being a little bit complex, and where talking through some of this stuff I hope is going to be super, super helpful for you if it hasn't been already. So the basic logical framework of this solution path is first find the price of the item, then subtract the deposit that's already been paid. That's essentially what we want to do. There's many ways to do that and like set up the math. I'm just giving you the way that I like to do it that I think is repeatable for the widest number of people. But if you have your own way of thinking about percents and you get that right 100% of the time, great, great. By all means, don't change. So even though we can use the translation approach to get there, I do want to acknowledge it's a slight variance from some of the more basic versions of using that approach in the past. So if you got confused on that, that's okay. This question is a learning opportunity, and you will see that type of pattern come up in future official guide questions if you choose to engage with the new official guide, which I recommend. So let's execute on this and try to make it a little bit easier for you on future problems. So we've set up our equation to find the original price. So let's go ahead and just solve that equation. Again, that's 10 over 100 times P equals 110. Again, many ways to execute the algebra, but I'll start by isolating P. And to do that, I'm going to divide both sides by 10 over 100. That's the same as multiplying by 100 over 10. And if you want help manipulating fractions because you're just starting out with this process or you're not feeling solid with your approach, we've got an episode on how to upskill with fractions linked below. And that's going to get us P equals 110 times 100 over 10. You can perform the math however you like, but I would probably just divide 100 by 10 to make it 10. So we'll wind up with 110 times 10, which is just 1100 or 1100. So there's a lesson on long multiplication below if you need some help with your long multiplication skills. I did when I started out, just for the record, okay? Now we know the original price of the item. That's 1100, but please do not pick D. You can probably imagine folks doing that at this point, though, just thinking like, oh, I solved for something and it's in the answers. I'll pick it. Look at that. But we don't want that. I know that's super tempting. I fell into that trap hundreds of times before I developed a lot of the skills that I needed to perform better on the exam. A lot of us have just been conditioned in math classes in the past to just think that way, like, oh, cool, there's my answer, and the answer choice is, bam, I'm under such time pressure here. I got to rush. I got to get things done. Everybody, I got to move on to the next problem. But there's a balance between going at the right pace and making mistakes that cost you problems that you absolutely should be getting right. So we want to calibrate that balance. One of the ways that you can do that is to just take notes on word problems. Just take notes. Write what's given and what's asked 100% of the time. That's the simplest way to prevent this type of mistake. That alone should drastically cut down on the possibility of making mistakes like this, which, as you can see, are extremely common. Again, imagine 100 of the brightest minds in the young business world, future leaders of the world, and 15 of them are going for D. And I think that's kind of like being the person in the office or the person on the team in a business who's just like doing a bunch of work without considering anybody else's workflow or context of like why the work is being done. And we definitely don't want to be those folks. We don't need more of those folks. We need more folks who can be like, hey, I noticed you did this, and then point it out to them and help them. That's part of leadership, right? So this is hopefully the path that all of us are on, is mutually together joining hands and fixing these problems of the business world and the world at large. So again, just take notes. Just take notes on your word problems. Super simple, super high ROI. You can imagine people resisting that, just like I was saying, people often resist my suggestion from the previous problem. People often resist taking notes because they feel like it slows them down. Well, that's an accurate feeling. It is slowing you down. But would you rather make a bad investment quickly or would you rather make a good investment slowly? Obviously, there's a balance in real life. If I take 100 years to make an investment and it's a really good investment, I might miss some of my investment objectives, such as it paying off before I die. Who knows? Maybe we're going to 120 here or longer. Yeah, fingers crossed, everybody. But as of today's technology, most of us aren't making it too far past 100. So you get my point though, which is like there's a balance there. Somewhere between the extreme of being super lazy intellectually and just picking the thing that pops up on the page in front of me with no thought, and being so extreme that we're like crazily, obsessively trying to make things perfect while never delivering any finished products. Somewhere between those extremes is the sweet spot. And what I'm recommending is that you build a system that puts you in the right place between those two extremes, because neither of those two extremes is productive. Both of them are super counterproductive. And so my advice is just find a note-taking system where you wind up at the end of a word problem with what's given and asked written on your scratch pad. That's what I've found has helped the widest number of people. Very simple, very actionable. And yes, it'll feel a little bit slower, but usually with word problems, you'll notice that the slower you start them, faster you're going to finish them. This is just what I've seen. Even though it feels slower at the beginning, you'll probably wind up with less clock time because you won't have to re-engineer mistakes and resolve problems or pick answers like D. So all we have to do, if we had the question written on our scratch pad and maybe circled or emphasized somehow, is check that and say, am I done? And then say, nope, I'm not done. I have to subtract the deposit that's already been paid, $110 from the total price, which is $1,100. And that will get us the correct answer of 990. So here I recommend a little bit of long subtraction, unless you're 100% on doing mental math, which there are certainly people out there who do that, but that's extremely rare. I'm definitely not one of those people. So most of us should be writing out the math rather than doing it in our heads. 3% of people pick C, which is just $10 away from the correct answer. So think about 3 of those 100 brightest future minds of business going for option C. What are you thinking? You're like, come on, everybody. Let's be better. What's it going to take, everybody? You can do it. And it's my personal philosophy that leading others starts with leading ourselves down the right path. And that leading by example is not the best way to lead. It's the only way. This has been my experience so far. But if you have a different philosophy, I respect that. If you want help understanding how to do long subtraction well, we've got that linked for you below as well. You can just line up 1100 over 110. I'm not going to rehash the basics of long subtraction because they are covered in depth in that episode, and many of you will have already gone through it. But suffice to say that if we're not getting 990 on this problem, we have got some issues that we should address. And everybody's got issues that should be addressed. Well, I don't know about 100% of everybody, but it seems like the vast majority of us have things we can address, myself very much included. So let's get on with the addressing part and let's get better. Couple possible pitfalls here, like we talked about, mostly tied to the wording of the question, which also I think gets into the time pressure piece, which I talked about, and possibly not developing strong habits prior to test day. So if you find yourself still continuing to make mistakes on questions like this, even if you have adopted my suggestion of writing what's given and writing what's asked at the start of the problem, I'd really recommend doing some untimed work to build up better scratch work habits. Then you can slowly decrease the allotted time for each problem to gradually build the time pressure back up, while focusing on maintaining those good habits, of course. So don't be afraid to be slow before you're fast. It's a completely natural way to build good, fast habits, to just start slow and gradually get faster over time. So if time pressure is hurting what you're writing down and causing you to miss questions you know how to do, delete the clock, start totally untimed. And then once your habits are perfect, then you can use a count up timer to measure your quote unquote natural speed without any pressure on the problem. Then once you have that natural speed number, you can steadily decrease that a little bit on future problems and future sets until you are hitting the allotted time from the exam and performing good scratch work under those exam conditions. It might take a little bit of time, but I really think you're going to love the results. I have. Loved the results from me engaging with that process, even though it was a major challenge. And everybody I've ever talked to about this has been in the same boat. So that's a pretty strong data set. Super common, super common to struggle with accuracy, good execution, and time pressure. This is like part of the human condition for most of us. Most people feel extremely pressed for time in the quant section. So I don't want to diminish the challenge. I just want to let you know you can do it. Many have gone before you and done it. They were no different from you. They might have even been worse off than you are. And you don't have to love the process. It doesn't have to feel good 100% of the time. That is not required at all. And that's not even our objective to have it feel good 100% of the time. Our objective is to have it work. And on word problems specifically, I have done my best to give you a simple addressable way to handle that. But if you have your own way of addressing it, again, nothing against that. As long as it's working well for you, we're happy. So let us know if you get stuck or you need help at any point. Again, you can DM us at the GMAT Strategy on current social channels or email us at contact, C-O-N-T-A-C-T, at the gmatstrategy.com anytime. As always, my greatest hope is that this material will make your studies as easy and as painless as they can possibly be. If you want more tips and strategies for optimizing your performance on the exam, please head to our website, thegmatstrategy.com, which is linked in the description of this content, and check out our free video on how you can reach your dream GMAT score in half the normal time. In the meantime, this is a regular show, so please subscribe and please stay positive and stay consistent with your studies. Talk to you all soon.